Period.
Aye.
Right. This is going to be really easy. I don't think you're going to think this is difficult at all. We have to graph and solve linear inequalities. Now, up till now, you've been doing linear equations, which have equal signs. What are inequalities? Less than, greater than, and that type of thing. So that's why this is going to be a little bit harder.
Well, that's easy.
Okay?
Yeah.
Now,
Write this down as example 1.
who are you?
Bailey Pate.
Hey, Bailey. Okay, write down example 1. I'm going to pause for just a minute. Okay.
No.
Right. Now we have to
No,
tell
you
if
don't
the
get it.
ordered pair is a solution. So if, hold on.
Oh my God.
They're the worst picks of the board.
No.
X value.
Okay.
5 is the Y value. I can't see the color. Okay, so this is X, this is Y. So I've got to plug the 5 where the Y is. So 5. I have to plug the 4 where the X is less than 4 plus 1. Is 5 less than 5?
No.
No.
No, it's equal.
So what you're
That
saying
incorrect.
is this 4, 5 is not in the solution. So you would say, nope, not in the solution. What if it had an equal to underneath it?
Well, then it'd be
Then
equal.
it'd be equal.
solution.
The 5 is not less than 5.
I have a question.
This is example 2, and my name is Bryce Carlson, and this is example 2, so write it down.
Okay, so write your example down, and then you're going to label this is X, this is Y, and this one's easy because they're both ones. So I'm going to put a 1 where the Y is.
So it's
I'm going to put a 1 where the X is. And then you answer the math sentence. Is 1 greater than -6? Yes. So this point is in the solution for this.
So this is an inequality. So it's an
It's an
inequality.
inequality. All right, when you're graphing inequalities, above the line is going to be when you're shading greater than. Make sense? Below the line is going to be when you're shading less than. Okay? Now, greater than or equal to, you're going to have a solid line like this. So it's a solid line. And you're going to have a dashed line or a dotted line if it doesn't have the equal to underneath it. Okay, now I'm going to make this make sense by going through it. I just kind of wanted to give you an idea. But what are you going to have to do up here? Shade. You know in a number line how you shade one side or you shade the other side? Well, for linear inequalities, you have to shade the whole side. Okay, so. Okay, you really don't have to write these 3 steps down, but we're just going to say what they are. Okay, the first step for graphing inequalities is to solve for y. Put it in slope-intercept form. So the first step would be solve for y, if it's not already done. Your second step is to graph the boundary line. Now, for less than or equal or greater than or equal, you use what kind of a line? I just said it. A solid line. So these are solid line. And what about less than or greater than? A dotted line. Okay, the third step is to shade the half plane. That just means shade above for what? Greater than. Shade below the line for less than. All right.
This is actually Aiken with example number 3.
Yes. Okay, so all you need to write down is 5x plus 2y is greater than -8. Okay, and what's the first step that we just talked about?
Slope-intercept form.
Slope-intercept form. Same thing as what your test was over. So I need to move the 5x to the other side.
Is this example number 3?
No, it's
Okay.
4. Alright, guys.
This is Allison. Write down example number 4.
Okay, write it down. 4x minus 3y greater than 12. By the way, do you see how good you have to be at solving for y? Got to be good at solving for y. So that's going to be our first step, is to move the 4x to the other side.
Why do you do the X first?
Because you can't divide first. You have to get the y by itself, and then you can divide.
Alright.
Okay, now do you remember something about dividing by a negative? Flip the sign. So y is going to be less than
Dang it. I hate that.
positive 4/3 x minus 4. Now sketch your graph. Where do I start? Negative 4 is the y-intercept. 1, 2, 3, 4. And then I'm going to rise. 4. Run which way?
Right 3.
Right 3. 1, 2, 3. Do it again. Up 4. Over 3. Dotted or solid?
Dotted.
Dotted because it has no line underneath it. So it's going to be a dotted line. Whoa.
And it's going to be on the right side of the...
Okay, now I have to shade less than, which is below the line. So where's below the line?
Bottom right.
Like the bottom right. So then you just shade however you want to over here. Okay, draw a sun at the top of your y-axis.
Okay.
Okay? Greater than is where the sun is shining. Less than is where the sun don't shine. So this is less than is where the sun don't shine.
That made me pee my pants.
This is Emily Mahana with example number 5. Ada has 285 beads to make jewelry. A necklace requires 40 beads, and a bracelet requires 15 beads. Write a linear equality to describe the situation.
Okay, so the first thing you have to do is say X is the number of necklaces and Y is the number of bracelets. That's the same thing as saying independent and dependent. Okay, so then our second thing we're going to have to do, so we have to write an inequality. Now, it says at most. You see that word at most? That means what? At most. Can I have more than?
No.
I can only have less than. Can I equal? Yes, so it's going to be less than or equal to for the word at most. Okay, my necklace beads, I can have 40, it's 40 times X, plus the bracelet beads are 15 times Y. At most is less than or equal to 285. Do we need to look at what the words were again?
No.
I kind of think I want to.
No.
Because I want to. Okay, so at most 285, so that's your less than or equal to 285. A necklace is 40 beads, so that's 40x. A bracelet is 15 beads, so that's 15y. Okay, so we have that. All right, now we have to solve for y. So you wrote that equation down, now solve that equation for y. I'm going to subtract the 40x from both sides. You're doing this on your paper.
What?
Subtract 40x. The next step is to divide by 15. Now this PowerPoint that I had shows the 15 dividing under one of them, but I usually do both of them. Okay, so now watch. 40 divided by 15 reduces to 8/3. Did you get that? Negative 8/3. And then 15 goes into 285, 19. Okay, now that we solved, now we can draw a sketch of a graph. Now, since this is talking about beads for necklaces and bracelets, I can only do the first quadrant. Okay, so my next step is to graph this. I just said can't make negatives, so we're going to graph this, use a solid line. Why am I using a solid line? Greater than or equal to. So, I'm going to do 19. This one's kind of weird. I'm not going to give you really weird numbers you have to graph. Start up here at 19 And then you would actually have to go down 8 over 3, down 8 over 3, down 8 over 3, down 8 over 3. And I'm just going to tell you for today and for notes, it ends at 7. Why is it going down?
Because it's negative 8.
How many did we start? What's the maximum number of bracelets you can make?
19.
With no
Necklaces.
necklaces. Okay, because what is this 19 called? Which intercept?
Y.
And that is X. Oh. Now, since it said less than or equal to, we have to shade below that line. Now, notice I didn't go shading out here because that would be negative. So you have to shade underneath the line, and then you're limited by the X and the Y axis. This is go.
This is Jasmine Cockrell. For example 5. Get 2 combinations of necklaces and bracelets that Ada can make.
Okay, so this shaded part means what? All the possibilities. Okay, so you just have to pick any 2 that are in that shaded part. Is 7 2 in the shaded part? No. So pick 2. Lane is dying to talk. So Lane, can you please give me a point that fits in there? Pick an X.
3.
3. Okay, now pick a Y that's in here.
17.
Oh, whoops, that's way up here. It's out of the shading.
Oh,
yeah.
3.
3 3, he says. 3 3. Does that work?
Yeah.
Okay, 3 3. Alex has been dying to talk. Alex, pick one.
I picked that one.
Tell me numbers.
That one.
Now pick his.
That
Pick-
one, yeah, that
Pick
one.
a number 1 to 7.
4.
4. Give me another number.
It's 7.
4 7. Ooh,
That's a close one.
that's
a
really
good one.
close, but it looks like it works. 4 7. All right.
Will 0 0 work?
0 0 will work. Oh, as long as you have, yes, 0 0 will work. Is this a dotted line or a solid line?
It's a dotted.
Solid.
Solid because there is an equal to. Now, what about a point that's on the line and it's solid?
Yes.
We're good. What about a point on the line that's dotted?
No, because
No go. It's not included. All right, that's all for now, guys.
Bye.
Say bye.
Bye.
Bye.